Hello and welcome back to another Future Dog House production. Let's continue our journey on bacteria, introduction, chapter 1 from this book. Alright, we are on bacterial DNA, ribosomes, and plasmids. Oh my. Bacterial DNA, ribosomes, and plasmids. Oh my. Here we go. This is a bacteria, okay, for this illustrative purposes. It's a bacteria. Yes, it doesn't look like either a cocci or a bacilli or a spiral shaped form, but who cares? The point I want to get to you is that this bacteria has a singular circular double-strand DNA. What do humans have? Oh, they have a double helix shaped DNA, don't they? So there's a difference. Why do I need to know these differences? Because of these differences, we can attack the differences using chemical agents, like medicine. All right, here we go. Plasmids. Ooh, plasmids. These are nasty. These are double-strand DNA. Hey, wait, isn't that like the double-strand DNA that's the bacteria DNA? Yes and no. These fragments of DNA contain antibiotic-resistant genes. Oh my, that's dangerous. Yes, this is the reason why many of the bacteria that we are facing in the next few chapters that we will be talking about are antibiotic resistant because of these genes, okay? The bacteria are smart. They figure out which genes that they need to protect themselves from antibiotics, and that's what happens here. Ribosomes. Yes, bacteria, like humans, like eukaryotes, they have ribosomes. And yes, the ribosomes come in two different types of subunits. A smaller subunit, which is in brown, and a larger subunit, which is in purple. And these are the ribosomes of this DNA. Now that we've talked about this, let's talk about why we care, okay? Why do we care? All right. Ribosome has different sizes. We have a small subunit and a large subunit. We just talked about that. And the sizes are different when you are talking about different organisms. A prokaryote's ribosome size is 70S. A eukaryote's, you and I's, ribosome size is 80S, okay? And the small subunit and the large subunit are also different in sizes too. 30S for the smaller subunit and 40S for the smaller subunit for the eukaryote. 50S for the large subunit for the prokaryote, 60S for the large subunit size for the eukaryotes. How am I going to memorize all this? Help me! That's where I'm here. That's why I'm here. That's why I do this. All right. Prokaryotes have even number sizes. Sorry, odd number sizes. Odd number sizes. 70S is an odd number. 30S is an odd number. 50S is an odd number. Future Dog House, stick to medicine. You don't know math. Those are even numbers. You're right. But the 7's an odd number, the 3's an odd number, and the 5 is an odd number. Get it? Oh my God, you're a genius. Thank you. I appreciate that. Eukaryotes, E for even numbers. E for even numbers. Eukaryotes, 80. 8 is an even number. 4 is an even number. 6 is an even number. Oh, I'm glad we talked about that. Now, why do we care about the 30S and the 50S? Because prokaryotes, bacteria, they have a 30S subunit and a 50S subunit, larger subunit, and these can be attacked by certain different types of drugs, like these two classes we're going to briefly talk about. There's many more drugs, we'll talk about that in the future, but I just want to mention that this is important since we're in the introduction of this bacteria chapter. Let's talk about this. Tetracycline. This class of drugs, tetracycline, attacks the 30S small subunit, okay? And the 50S subunit, erythromycin, this class of drugs attacks the 50S larger subunit of the bacteria. Simple as that. So, if you like this video and you want more of these videos, please click subscribe. Thank you and have a nice day.
Congratulations! You are a medical student. One day, you will be a qualified doctor and your home will be a hospital or a clinic. But for now, your journey begins in the lecture hall. You will listen to countless hours of lectures and spend evening after evening in the library reading page after page of medical theory. And guess what? This is the easy part. The hardest part is retaining your medical knowledge so it's there when you need it. For example, examinations. But don't worry, we are here to help. Meet Jeff. Jeff is a good student. He goes to all his lectures. He says no to parties so he can stay late in the library. But when it's time to take the exams, Jeff freezes. The knowledge that he spent so long learning just isn't there anymore. Now meet Jennifer. Like Jeff, she is a good student. But instead of just reading textbooks late into the night, Jennifer uses technology to help her study. She also watches lectures on YouTube and practices her knowledge with QUPI, a medical quiz app and online platform. Jennifer likes QUPI because it has 10,000 practice questions covering her entire medical course. This means she can practice her medical knowledge from anywhere and in a way that actually prepares her for the exams. Because she is practicing with exam-style questions, when she takes real exams, she'll be ready. Don't be a Jeff. Begin your 7-day free trial with QUPI today.